Why weather forecasts are hard to get right, the science behind predictions. Ever wondered why weather forecasts sometimes miss the mark? Despite incredible advancements in technology, weather forecasting remains one of the most challenging tasks. In this video, we'll explore the complexities that meteorologists face when trying to predict the weather accurately. Weather forecasts, especially short-term predictions, can be impressively accurate. A 5-day forecast, for example, can predict the weather with about 90% accuracy, and even a 7-day forecast holds up 80% of the time. But as we extend the forecast window to 10 days or more, accuracy plummets to just 50%. Why does this happen? Well, the atmosphere is constantly changing. Weather models rely on initial conditions and estimates, but over time, these estimates become less reliable. The further out we go, the more chaotic and unpredictable the system becomes. We can only collect data from the present, there's no way to measure the future directly. Weather models have to use assumptions to make predictions, and small errors in those assumptions can grow exponentially. That's why short-term forecasts tend to be more accurate, while long-term forecasts are more of an educated guess. So how do we collect data for these models? The National Oceanic and Atmospheric Administration, NOAA, operates several types of environmental satellites. Geostationary satellites, like the GOES-R series, hover about 22,000 miles above Earth. These satellites remain fixed over one area and provide near-continuous data on current weather conditions. They're particularly useful for tracking severe weather, like hurricanes, as they form and move. Polar orbiting satellites, such as those in NOAA's Joint Polar Satellite System, JPSS, travel from pole to pole and give us a full view of the planet twice a day. These satellites are critical for long-term weather predictions, collecting high-resolution data on the entire Earth's atmosphere, clouds, and oceans. These satellites gather essential information, such as sea surface temperatures and radiation emitted by the Earth. This data is fed into weather models, helping meteorologists predict not only day-to-day weather but also larger seasonal patterns, like El Niño and La Niña. Polar satellites can also map environmental hazards such as droughts, forest fires, and poor air quality. Polar orbiting satellites are crucial for accurate weather forecasting. By measuring energy emissions from the Earth and atmosphere, we can assess longer-term trends and make better predictions about severe weather events, like hurricanes and tornadoes. Then there's NOAA's Deep Space Climate Observatory, or DSCOVR, which orbits 1 million miles from Earth. While its main job is to monitor space weather, DSCOVR also provides crucial data on solar radiation and Earth's atmosphere, which helps with air quality forecasts and climate monitoring. Thanks to the combined efforts of these satellite systems, weather models have become more sophisticated and reliable. For instance, the wealth of data from polar orbiting satellites allows meteorologists to make accurate forecasts up to 7 days in advance. But even with all this technology, the atmosphere's chaotic nature makes it difficult to predict the weather perfectly beyond a week. Of course, there have been times when forecasts have gone wrong. Weather systems can shift unexpectedly, and even the best models can't account for every factor. Severe weather, in particular, can be unpredictable, making it hard to forecast flash floods, tornadoes, or sudden storms with complete accuracy. However, advancements in technology are making a difference. With improved data collection, machine learning, and better computational power, we're seeing more accurate forecasts and better preparation for extreme weather events. But meteorologists continue to face challenges as they refine their methods to give us the most reliable weather predictions possible. Despite the challenges, weather forecasts are vital in our daily lives, helping us plan and prepare. So the next time you check the forecast, remember the science and technology behind it. Thanks for watching. Don't forget to like, share, and subscribe for more insights into the fascinating world of science and technology.